At this point, what I want to do is introduce two other members of the Particle team, Calvin Jepson, who's our Senior Manager of Solutions Architecture, and Ian Archbell, who's a Group Product Manager and also the Product Manager for Particle's tracking system, to give a demonstration of the new tracking system and to share a bunch more exciting details about the hardware and software that we're delivering today, or that we're announcing today, rather. So without further ado, I'd like to turn the mic over to Cal, who's going to walk us through the rest of this presentation.
Thanks, Will. Very excited to be here. And I know that me and my solutions architecture team are really excited about these new product enhancements that you and the product and engineering team have been working so hard to build. So thank you. So as Will mentioned, I'm going to give you first ever demonstration of the particle asset tracking services made up of the location services and the configuration services. So without further ado, let's jump into it. For anyone unfamiliar with what you're looking at right now, this is the Particle console. It was built to be the command center for your fleet of IoT devices. There's a lot of functionality in here that I won't be reviewing today, but suffice it to say the Particle asset tracking SOM and asset tracking products all inherit that functionality. And what I'm alluding to is fleet health, the ability to push firmware over the air, integrations, etc. But let's focus on the asset tracking services. So jumping over to the map. For the June release, as Will mentioned, we will be enabling 3 different location lookup modes: last known location, historical location, and live location. Last known location is exactly what you're seeing on the map now and is very, very intuitive. It's showing the last location your fleet of devices has reported. Historical location, also intuitive, except it takes a query in the form of a start and end date, for example, last Saturday, and it will render all of the locations your fleet of devices have been in that time range. So for example, this is me taking a trip from my apartment in San Francisco to Golden Gate Park. Onto the third and final visualization mode is live location, which you can see indicated here by a pulsating marker. To demonstrate this behavior and the entire system in action from soup to nuts, let me show you a video I took over the weekend. To take this video, I zip tied a particle asset tracker to my DJI drone and took it for a ride. While I was piloting this drone, my colleague Eric was taking a screen capture of the map in the console, which you can see superimposed in the top left-hand corner. As this video is playing, take notice of 2 things: the GPS accuracy and the network latency. The particle asset tracker, as Will mentioned and Ian will get into, has 2.5 meters of CEP50. CEP50 is a measure of probability a device falls within a certain range, and it's an industry standard. You can look it up. You can see a nice view of Sutro Tower at this point and down to the Sunset District. For situations where GPS location is unreliable, like urban canyons that make up large cities, the particle asset tracker can utilize its IMU for dead reckoning and Wi-Fi modem for Wi-Fi locate. So you can always be sure you're getting an accurate location. When discussing latency, it's important to note the technologies that we're using under the hood, namely a dedicated and encrypted MongoDB server on the back end, and we're using Mapbox on the front end because of its ability to render large data sets with low visual latency and immense customizability. All right, video's over. Now that we've seen how we're visualizing this new data, let's take a look at the raw data that these devices are actually collecting and publishing up to the cloud. So jumping back to the console here, into the devices page, I will drill into one of these devices, which is Tracker 1.2. On the left-hand side here, you can see the live event stream of data being published by this device. Clicking on one of those events, you can see the payload of said message. And in here, you can see latitude and longitude, altitude in units of meters, heading in degrees from north, and the horizontal and vertical accuracy. These are the CEP numbers I referenced beforehand. Also, you have a trigger reason, which I'll circle back to in a moment, and this request ID, which is an acknowledgement ID that the device uses to make sure data has been successfully communicated between the device and the cloud. Now, it's worth mentioning here that future iterations of the asset tracking firmware will actually allow you to embed your own data inside this payload, temperature, pressure, whatever it may be, and that data will be stored and served by the Particle platform for you to use with the Cloud API. Now, before moving on from this page, I actually want to stop briefly on the Vitals page here. Device Vitals is something that we released for all of our devices last year, and something that our product and engineering teams have been using to drive reliability and performance improvements, and something definitely worth checking out if you haven't used it much already. Okay, circling back to the trigger logic I alluded to earlier. This brings up the question, what logic determines when a device will report its location? Is it time-based? Is it distance-based? Is it motion-based? The answer to this question brings us to a new service that Particle is debuting in June, called the configuration service that Will mentioned. This service, as he said, provides instantaneous control over the behavior of the publish mechanisms inside the asset tracker. The initial ways you could control this are based on distance. For example, if you change this radius trigger right here to 20, that means whenever your device moves 20 meters away from the last time it published, it will publish a new location. Another way of doing that is with this time, these time configurations, defining the minimum interval and maximum interval with which your location will be published. In addition, we also have the ability to define specific movement sensitivities. So low movement sensitivity would mean, disabled mean I wouldn't publish whenever the IMU is measuring movement. Low sensitivity mean it would take a lot of movement for me to publish a new event, but then medium and high also. To demonstrate a little bit more graphically how these work, let me show you some flights I took over the weekend with my drone with 3 different configuration profiles. So in here, you can see 3 different laps I took with the asset tracker tied to the drone with 3 different profiles. The first profile, the time profile, essentially publishing every 3 seconds, regardless of what's going on and where it's moving. And you can see that based on when the drone was going slower, the distance between these 2 points is a little bit closer than when the drone was going faster in a straight line. Over here, the motion profile, very interestingly and expectedly, is publishing a lot when it's going around these turns, essentially when there's a lot of acceleration occurring for the asset tracker. And then the distance profile, similarly, you're disabling any sort of time-based publish or motion-based publish, but you actually have a publish every time your device has moved 25 meters from the last time it published. Now, it's key to mention that in between each of these different runs, I didn't have to flash firmware. I didn't have to take the device down. All I did was go down, change these parameters here, and hit save. And while this is only a single device, if I had hundreds of devices in my fleet, it would push all of those updates to all devices with a simple click of the button. Now, it's important also to note that while we're only limiting the configurations to these, call it 10 different parameters, in future releases of Device OS and the Particle platform, you will be able to configure and build your own configurations that you can use for whatever logic you're using on your device fleets. So with that, this concludes my demonstration of the software that we're shipping in June. Stay tuned in the coming months for some cool features, as I mentioned, being able to embed your own user data into the published payload, as well as dynamic configurations.